Okay, so we have a 6-month-old infant who has been brought in with failure to thrive, and labs show uric acid in the urine. MCV is 103 with hemoglobin of 10. Anemia doesn't correct after vitamin B12 or folic acid supplementation. He is diagnosed with uric aciduria. What would decrease uric in the urine? So is it A, adenine, B, guanine, C, carbonyl phosphate, or D, uridine? So I'll let you answer the question and then I'll explain in 5 seconds. Okay, so the answer is going to be D, uridine. So moving down. So in this case, this patient has uric aciduria, which is an autosomal recessive problem. So just going back to biochemistry. So we have the pyrimidine synthesis pathway, which is necessary for creation of the building blocks for RNA and DNA. And so for that, the problem here is impairment of these enzymes. So oratidylic pyrophosphorylase and oratidylic decarboxylase. I'm probably saying these things wrong, but essentially you're giving uridine or cytidine bypasses the problem. So since you have a problem in the pathway, so if this is the case, if these two enzymes are impaired, then that's going to create a traffic jam. And so giving uridine actually just bypasses that traffic jam and helps you create the end product, which is going to end up inhibiting the origin of the pathway. So it's necessary, like I was saying, for RNA and DNA synthesis, and then it's going to increase UTP, which inhibits CPS2, right? So I guess to make it a little bit clearer, and then that's going to decrease uric acid, which is the problem in this case. And so just to review pyrimidine synthesis, we start off with glutamine and CO2, and then we have CPS2 that I was talking about. And so these two create carbonyl phosphate, and then it's added with aspartate to get N-carbonyl aspartate. That leads to dihydroorotate. Orotate adds with PRP to create OMP, UMP, and CTP. And so these two are necessary for the pyrimidines to help incorporate them into RNA and DNA. And then in terms of the other answer choices, as you can see from that pyrimidine synthesis pathway, carbonyl phosphate is actually upstream, so that's not going to help. And adenine and guanine are actually purines. So these, what we're talking about, are pyrimidines, and these are purines. So that's going to be a different pathway. So once again, so the problem here is we have too much of this, right? So we have too much uric acid, and so we're giving uridine, so it's going to essentially bypass. So if you have a traffic jam here, you're essentially creating a diversion by just going straight over here. And so that way you can bypass the problem. It's going to end up creating the necessary end product that can go back up and then help inhibit the original enzyme, which is CPS2. So it stops, if you can help create the product that inhibits this, then that goes all the way downstream and stops this from being produced. So that's how you help fix this problem and help improve this patient's quality of life. So in summary, for this one, you just had to recognize that they give you the diagnosis in this case, and then one caveat is we're talking about anemia, and so we have a megaloblastic anemia because first of all, hemoglobin's low, so we have anemia, and then to decide what type of anemia it is, you look at MCV. So if it's MCV 80 to 100, it's going to be normocytic. If it's below 80, it's going to be microcytic, and if it's above 100, it's going to be macrocytic. And so that just means it's a bigger RBC, but in this case it's megaloblastic because we tried giving vitamin B12 and folic acid, and both of those things did not correct it. So that's why we decided that it's a megaloblastic anemia. But that's besides the point, because the only thing you needed to know was the diagnosis, and with that you can recall the entire pyrimidine pathway to understand what you need to give to help bypass the problem and then help fix fix whatever the question was asking, which in this case was decrease orotate in the urine. So I hope that helped, and thanks for watching.